Okay, this is the second part of this lecture on using morphology and corpora. We've looked so far at actual corpora of texts, but a different type of resource that you can work with are lexical data sets. And most of my work is based on using lexical data sets, and I think you can do quite a bit. So this section is a little bit reproducible because I'm not going to share with you two of the data sets, but if you really want them, we can work something out and I could send them to you. The problem is that they are being published right now, so we cannot share them directly. But if you're interested, to send me an email. Let's start with your favorite language, Russian. And we want to load a Russian paradigm, and this paradigm is a dictionary of Russian inflection. The dictionary contains a base and all the inflected forms of that lexeme. In this case, for example, abak, you get all the different forms for all the cells of that lexeme. And in a relatively recent paper, I developed a method for extracting markers automatically for languages, and this is what you see here in the following columns. You see the markers of each lexeme as extracted by this software. And this, if you're for the clever, it's clear that this is all transliterated. The transliterated was done automatically, so there are a couple of mistakes. For example, instead of transliterating OU, it transliterates without the palatalization, but it's quite close. There is some overabundance in this data set. This is quite common for Slavic languages. I don't know whether you've already heard about overabundance. Overabundance is when a lexeme has two different realizations for the same cell, or where two forms compete for the same cell in the paradigm of a lexeme. And that's what's happening here. Basically, for abaka, I think that's how you pronounce it, for abaka you have two alternatives for the instrumental singular. You can either say abakoi or abakoi, and you see that both markers have been extracted correctly here. And we can do the same as we did before, which was looking at the distribution of frequencies. So here I am counting the distribution of the frequencies of the different markers. We can start with the nominative singular. And you see here the nominative singular markers. This O with the dashed line means no marker. Maybe I have something here. What that means? Yeah. So, for example, for A, which is just the letter, you see that there is no marker because there is no contrastive material. So, for the formal definition, a marker is contrastive material, and the stem is whatever appears in all the cells. Yeah. In a less trivial case, again for abaka, you see that the genitive plural is zero mark, so we can look for the genitive plural, and you see that it's abak, and it is zero mark because this sequence abak appears across all cells of the paradigm. It's not because that's the base, but rather because that's what's constant across all cells. So now we are a little bit closer to working in word and paradigm morphology. Notice that we're not defining morphemes, we're just making an opposition between contrastive and non-contrastive material, and the markers are just the contrastive material. So to come back to marker frequency, you see that basically marker frequency also follows a Zipf distribution. You could be thinking, well, that's just a nominative singular. What about the rest? Well, we can do it also for the rest. Here are all the cells. Let me make this a little bit smaller for you. I think you can see it there. These are all the cells, and you see that basically all of them behave more or less identically. Not completely identically, but very close. Some cells have a very, very large contrast between the most frequent marker and the rest. For others, the contrast is less marked, strong, but you can still see it. And the basic principle, as before, is maintained. Some markers carry most of the frequency, while others have very little frequency. We can do the same for inflection classes, and we define inflection classes as basically the set of all markers in the paradigm of a lexeme. And if we count inflection classes, there are quite a few for Russian, and you see that they follow also the same type of Zipfian distribution. And if you see here 100 inflection classes, you might be a little bit surprised if you've done Russian before, because the common knowledge, or the given knowledge, is that Russian has either 3 or 5 inflection classes, but that's only really possible if you make a lot of abstractions and if you ignore a lot of the actual data and the actual variation in the data. You can find 5 inflection classes if you just look at the most common markers across nouns and ignore everything else. But here, this is including everything. Now we're going to focus on U-shaped distributions, which is a different kind of distribution, and which, as far as I am aware, only happens in overabundance. We'll be looking at Czech, your favorite language, which is a Slavic language, and we've been working on this with Bonami for quite some time. Basically, here we want to look at what happens with overabundant lexemes. We have a very large data set with many holes because we have quite a few forms missing, but we'll focus on a subset, which is hard inanimate nouns in Czech. And from hard inanimate nouns, we will focus on one particular cell, which is the locative singular, because this has a well-known alternation between U and Ye. So, for example, some lexemes can appear with U in the locative singular, like dub, which is oak tree, and dum appears with Ye, which is house, so domium. However, there are quite a few lexemes which can appear with both. The distribution in our dataset looks like this. We have 10,000 nouns which can appear with U, 4,000 with Ye, and 400 which appear with both. So we're going to look at this, at the ones that appear with both, and we can look at their distribution with in the corpus. This can be ignored. Right, so here's an example of the distribution, and you can start seeing the problem. The issue is that it is very easy to be certain that a lexeme is overabundant if you see it with both forms. However, if you only see one form, you don't know for certain that it isn't overabundant, because while for some lexemes, like this one here, I'm not going to try to pronounce it, only after 12, this is the same lexeme appearing with 2 different forms, only after 12 instances in the corpus you already saw it with both forms. However, here's a different example with a more extreme distribution. Has 80 hits in the corpus, but only 1 with Ye. And here's an even more extreme example, or even here, which appears 15,000 times only with U and 2 times with Ye. So if you had only seen 50,000 archive, then you might have missed this, and you may have falsely concluded that it is non-variable net. Well, it actually is. So this is difficult, and we want to look at the distribution of markers. This is a plot of the relative frequencies or their absolute log frequencies with the different markers by lexeme. What you see here is that U is preferred over E. But much more interesting is if we plot the proportions. So here's the proportion of U by lexeme, and you essentially can see exactly what I was talking about. So there are quite a few lexemes with very low proportion of E, while there's relatively few lexemes with a low proportion of U. But we get this very nice curve in the middle, meaning that all different proportions are attested. And we can also plot it as absolute counts, and we get what I was talking about before, which is this U-shaped distribution, which basically show you that most lexemes strongly prefer either Y or U, but you get everything in between. And this is only lexemes which are variable net. So this is ignoring the lexemes which do not appear with one or the other. So yeah. Finally, I'm going to talk a little bit about marker length across languages. This is from a different paper which should come out in a few weeks from now, hopefully, if everything goes well, where we looked at markers across different languages. For this, we used the Unimorph dataset, which is here, which is a collection of inflectional datasets. This is quite interesting, and it might be very interesting for some of your projects because you have a very large variety of languages, and you can download them for free. They have a very wide selection. So for example, Armenian, you can go to the repository and you can take a look at what they have for Armenian. So you possibly don't speak Armenian, but this should be quite clear. You have the lemma here, you have the inflected form in the second column, and then you have the cell. Yeah. So this Unimorph data set, the database is very, very useful for cross-linguistic studies or even for single language studies. Most of these are compiled from Wiktionary, which contains many errors. Some are from the SORI database of Ottoman languages, which is much better, but still they are quite usable. So from this data set, we extracted the markers for all the language for most languages which were at the time in the data set with nominal inflection. So we only look at the nouns, and we try to standardize as best as we could the orthography using a Bitran for the languages which are supported, and for the ones that aren't, they usually have a pretty straightforward orthography. We ended up with 68 languages in our dataset, and they have different numbers of lemmas, as you can see. If we were to plot it, we would get also a very Zipfian-like distribution, but we're not going to, not yet. And there is quite a bit of variation in terms of marker length across these languages. So you see here that for Quechua you have markers between 0 and almost 20 segments, while for other languages like something like Latvian, the variation is between 0 and 5 segments, with most having 2 or 3. So there is quite some variation, but still we were interested in marker length versus frequency, so frequency within language. And if we plot the raw frequency of the marker against its length, we get something very familiar. but it's not perfect, but we can make it better. So to make it better, we standardize the frequency within language. So we scale it, and this is what we get, which is again a very similar concept of this of the Zipfian list effort principle, where you see that high frequency markers tend to be shorter. So it's not an implicational thing. So if you have if you're very long, you're going to be low frequency, but being low frequency doesn't actually mean that you are going to be long, if that makes sense. So we thought this was quite interesting. We did some further models on this, but this is the main takeaway. So this idea of frequency and length doesn't only apply to words, it also applies to inflectional markers, and it applies across the range for many different languages. So that's the second part. I hope you can take something away, and that you might be interested in doing some computational morphology and computational typology, and that's basically it. I'll see you tomorrow for the Q&A.